Okay, the next hand would be if it's two pairs. So that's another function. So we're going to check the denominations. We'll pass that as an argument. And to check for two pairs, I'm going to create a counter. I'll initialize it to 0. And then I'm going to do another for loop, 0 to 12. And we are checking if there are two cards with the same denominations. So if dnums with the index of dnum equals 2, then we have a pair. And we will increase the counter by 1. So our count plus equals 1. So after we finish the loop, we'll simply check the counter. If the counter equals 2, then we have two pairs. We found a pair and then we found another. Otherwise, we can return false because we don't have two pairs. So if our count equals 2, then we can return true. Otherwise, we'll simply return false. And another hand would be one pair. So I'm going to copy paste the whole function because it's gonna be very similar. So it's gonna be is one pair. And I don't need to do the counter here because once we hit one pair, then we will return true. So if our dnums over here equals 2, then we will return true right away. We don't have to count another pair because we're just checking whether there's one pair. Otherwise, we will return false. So this is for our one pair. Now there's still two more that we need to do, which is the straight flush or just straight. Now the straight flush we will check a little differently, but for the straight we're going to create another function that I'll just call isStraight. Now isStraight basically means if the denominations are consecutive. There's one little trick though. Remember, ace can be at the beginning like as 1, or it could be after king. So technically what we need to first check is if we have 4 consecutive, and then we will check for ace separately. So I'm going to pass hand in it as an argument, and there's one thing. I'm going to create another function which is going to be like a support function for this one, and I'll call it isAnySuit. And isAnySuit will take hand as well, but we will also pass the integer for the denomination. So what we are going to be doing here is testing for a 1 for any suit of the given denomination. So we'll pass the denomination and we'll check what suit it is. So I'm going to do a for loop that's for the suits, so 0 to 3, and now we'll check for a 1. So if our hand with the indexes of suit and denomination has a 1 in it, then we'll return true. Otherwise, after the loop, if true is not returned, then we'll return false. So now in our isStraight function, I'm going to create the denomination variable and assign it a value of 13 because there's 13 denominations. So now I'm going to find the highest denomination and I'm going to use the do loop. And I'm going to be looping until, and here's where I'm going to be calling the isAnySuit. So until isAnySuit returns true. So we'll pass the hand and denomination. Now our denomination is set to 13, so we'll start from the end and we'll go down and find what our highest denomination is by going one by one lower. So our dnum in our do loop will equal dnum minus 1. So let's say our highest denomination is 10. So we'll start with 13, come over here, do 13 minus 1, it's 12, and then we'll call the isAnySuit and we'll loop through it and see if there's any number 1 in our hand that corresponds with the index for the denomination of 12, and it wouldn't because our highest is 10. So then we go back here and we would be denomination now equals 12 minus 1 is 11. So we'll come over here and once again we will start looping and find out that there is no 11, and we'll go down like this until we hit the highest denomination that we actually have, and this will return true. So that will set our denomination to the highest card that we actually have. So after we find the highest card, we can check if that highest card is less than 4, because if it is, then we cannot have 5 cards straight. So basically we'll eliminate it right away. So we'll return false. So if it is not, then we'll have our highest card and we'll check the 3 cards before that. In other words, we'll see if the 3 cards plus the highest card that we have are consecutive. Again, we're only checking for 4 because of the ace. So we'll do a for loop, and we're going to check 3 cards. So we'll start from 1 to 3, and once again we will do an if statement. This one's gonna be with a not in it, so we will do if not, and we will call the is any suit, and we will pass the hand and the denomination. However, we want the 1 card before that, so denomination -1. Remember, we are looping through 3 times, so we'll start, let's say denomination was 10, so we'll start with 9, then 8, and then 7. And if they are all true, then we have 4 cards consecutive. If any of them is false, then we don't have 4 cards consecutive. So if not, then we can return false. So now we know that we have 4 consecutive cards. So now we have to find what the 5th card is. And we'll start with the special case when the highest card is a king. Because remember, king can have a straight with an ace. So that would be 10, jack, queen, king, and ace. However, if the highest card is king, another straight that can be formed is if the last card is 9. So you would have 9, 10, jack, queen, and king. So we're going to check if the highest card is king, and then we'll code an if statement to accommodate these special cases. So we will do an if, and if the denom equals 12, which is the king, and the last card is an ace, so we will simply call the is any suit and pass the hand, and ace is an index of 0, so we'll pass index of 0. We don't care what suit it would be. If there's any ace, then we'll have a straight. And now let's check for the 9. So, or if the denom is 12, again, if it's a king, and the last card is 9, which would be the is any suit, and again we'll pass a hand, and 9 as the face value of the card resides in the index of 8. Remember, first index is ace, so index of 8 refers to the face value of 9. So if any of these 2 conditions is true, then we can return true, because we have a straight. Another special case is if the highest card is 5. If that's the case, then the lowest card needs to be ace, because ace would count as 1. So we'll do an else if, and we'll ask if the denom has the index of 4, which is where the face value of 5 resides, and we will now check if there's an ace, so we will once again call the is any suit, and we'll pass the hand and ask for an ace, which is the index of 0. Then once again we have a straight. We'll have 1, 2, 3, 4, 5. And if neither of this is true, then the last possibility for straight is if the lowest card, remember we have the highest card, let's say it's 9, then in order to have a straight, the lowest card needs to be 5. So we would form 5, 6, 7, 8, 9. So basically we need to check if the last card is 4 smaller than the highest. So we'll do an else if again, and we'll just call the is any suit, and we'll pass the hand, and we'll pass the index that is 4 smaller than the index of the highest card. So it's the denom minus 4. So if such card exists, then once again we have a straight and we can return true. And if any of these if statements fails, then we don't have a straight, we can return false. And this is how we have the straight. So let's recap this. So first, we'll start with the denom as 13. Now remember, I added the comment here, our ace is index of 0. There is no card number 1. The deck of cards starts with 2, so 2 is index of 1. 3 is the index of 2, and so forth. So 10 would be 9, J or Jack would be index of 10, Queen would be 11, and King would be 12. So when we start with 13, we'll come straight to our do loop and we deduct 1. So 13 minus 1 is 12. So we're checking if we have a king. So we will simply go to our is any suit subprocedure or function, and we will see if a king exists. And if not, it comes back here, and now we will have 12 minus 1. So now that's 11. We're checking if queen exists. If not, then we'll come back again, and it's gonna be 11 minus 1. So that's jack. We'll check if jack exists, and so forth until we find whatever the highest denomination we have. Then we come over here and we check if the highest denomination is 4. Once again, ace is index of 0, 2 is 1, 3 is 2, 4 is 3, and 5 is 4. So we are basically checking if the highest denomination is less than 5. Because if it is, meaning that it's, let's say, 4, then you cannot have straight with 5 cards if the highest is 4. You can have ace for 1, 2, 3, and then 4, but the 5th card is not gonna fit. And you may be wondering what's the 5th card going to be then, and you have to remember that you can have multiple denominations with different suits. You can have, let's say, 4 of spades and 4 of hearts, for example. Then we come over here in our for loop and we will check if there are 3 consecutive cards before highest denomination. So we'll check highest denomination, deduct 1, that's the card before that, and we will see if such card exists. And if it does, then we have 2 consecutive cards. Then we come back here, deduct 1 again, so that would be the 2nd card before the highest denomination, and check if that one exists. And if it does, then we have 3 consecutive cards, and then we of course do it one more time for the 4th card. So if we pass, then we have 4 consecutive cards. So now we can check these special conditions for the king, and if there's an ace, or if there's a king and a 9, then we have a straight. Or if we have 5 and an ace combined with the 4 consecutive cards already, then we have a straight. And finally, if we don't have a 5 as the highest card or a king as the highest card, then we'll simply check if the lowest card is 4 smaller than the highest. Again, we already have 4 consecutive cards, so we're just checking the last card. And if that one is 4 smaller than the highest, then we have 5 consecutive cards and we return true. If all of these fails, we'll return false. Alright, so now we can go to our getScore and start calling these functions. So now we will determine the score of the hand. Now we'll start from the highest, because if any of this is true, then all the lowest will not be even evaluated, because we are interested on whatever the highest possible score we actually have. So if we have, for example, 2 pairs, then we're not interested if we have 1 pair, because obviously we do, but we have 2 pairs, which means it's higher than 1 pair. And the highest would be the flush. So we'll check if it's flush, and flush expects suits as an argument. So we'll check the flush, but we also, before flush, we can also check if also straight is true. Because if that's both of these are true, then we have a straight flush, which is the highest. And straight expects hand. So if this is true, so if we have a flush and straight, then we have a straight flush. So we can return straight flush. Now we'll just check for the other, which is just flush itself. So if this one's not true, the second highest would be flush itself. So if is flush, and we'll pass in the suits, then we can return a string simply called flush. If this one's not true, the next highest would be full house, so we'll check for that. And if it's true, then we will return full house. After full house is 4 of a kind, so we'll return 4 of a kind. The next highest would be straight, and after that is 3 of a kind, then 2 pairs and 1 pair. And if neither of this if statement returns the hand, then we really have nothing on our hand, so we will return nothing. So this is all our possibilities. So now let's go to our button click display and let's determine the score by calling the getScore and outputting the hand into our text box. And we will return the string from the function, so we will simply concatenate the result to it. So getScore, and we'll pass in the hand, suits, and denominations. Alright, let's test it. And let's test it first for the straight flush. So basically it means consecutive cards with the same suit. Let's say I'll start with 2 and all of them will be hearts, then 1 which would be for our ace, say 4, H. So if you arrange them, it would be 1, 2, 3, 4, 5, and I get a straight flush. So that is correct. Now if I change any of these suits, let's say from hearts to diamonds, I get straight. I still have 5 consecutive denominations. So here it is, the hand is straight. Now if I break the straight, let's say this one would be number 8, but I'll have the same suits, I'll get a flush, which is correct. The next one, let's test the 4 of a kind. So let's test if we have, let's say, all 2s, or 4 2s. So we'll have 1 heart, 1 diamond, spades, and 1 clubs. And I have 4 of a kind. So do full house, which is 3 cards of one denomination and 2 cards of other. So let's say 3 2s and 2 5s, and I have full house. That's correct. So next, 3 of a kind. So let's do just 2s, so let's say 7. I have 3 of a kind. If I change this one to, let's say, 8, I'll have 2 of a kind, or 2 pairs. I'm sorry, 1 pair. And if I change this one to 8, I'll have 2 pairs. Yep, so all of this is working correctly. I hope you liked it, and I'll see you in the next video.